Let's go to page 520. Okay. Number 1, it says sketch each angle in a standard position and indicate a rotation by curved arrow. Classify each angle by the quadrant. Okay, so for A is 135 degrees. So here's your 0, here's your 90 degrees, here's 180. So 135 is halfway between, so be right over here. Okay, and so that's the angle. And this would be quadrant 2. Okay, for B is negative 135 degrees. So negative 5, you start off here, it's going to go this way. So it'll be about right over here. Again, each quadrant is 90 degrees. So this is negative 90, negative 180. Okay, so it's halfway between. Okay. And this would be in quadrant 3. Okay, let's go to the next one. Okay, so you got 330 degrees. The easy way to remember is that on the clock, each number is 30 degrees. Okay, and so 330. If you go backward this way, okay, so again this over here, think of it as a 360. So you go backward. So 3 o'clock. This would be a 4 o'clock position. Okay, and this would be 330, and this would be in quadrant 4. Okay, so 3B is negative 330 degrees. So I have to go backward. So again, one number on the clock is 30 degrees. So you have to go backward 11 numbers. So you start off here, you have to go backward this way. Okay. So from here it'd be 3, 6, 9, 10, 11. So you're going to end up at 2 o'clock position. Again, negative 330, so you have to go this way. So this would be in quadrant 1. Okay, let's go to number 5. Okay, number 5 is negative 270 degrees. So you're going backwards, so from here you go 90, 180, 270. So it'd be right over here. And in this case, this would be a quadrantal angle. Okay, because it's around the quadrant. Okay, number 7, 290 degrees. So each quadrant is 90 degrees. So you go from here, you go 90, 180, 270, and 20 more. Okay. So this would be in quadrant 4. Okay, let's go to number 9. Number 9 is 495 degrees. Okay, so I'm going to minus 360, so I get 135. So one thing is I'm going around a circle, so that's 360. Okay, so you can go around the circle one time, that's 360. Take care of 360. And I need to go 135 more, so I'm going to go all the way to here. Okay. So again, we already did 135 before. Right? Okay, so this would be in quadrant 2. Okay. Okay, let's go to 11. Negative 450 So whenever you're going to get whenever you have the angle, if it's really big, you can go and look for the coterminal angles. And you can do that by adding 360 or subtract 360. Okay, so if you add 360, this will give you negative 90. Okay, so in other words, you have to go one circle and go another 90 right over here. And so this would be a quadrantal angle. Okay. Okay, let's go to the next one. Okay, number 13. We're looking for 2/3 of the revolution, and it's counterclockwise. So counterclockwise is going this way. Okay, so 2/3 of the revolution, probably it's easier if you convert into degrees first. So 2/3 of the revolution, you times it by 360 degrees per revolution. Okay, and so this will cancel out. So this will equal to 240 degrees. Okay. And now if you want to put in a label, so to be more exact, you got 2/3 of revolution. Okay, you're going to times it by 360 degrees over one revolution. Okay, again 360 degrees per revolution. So the revolution will cancel out. Okay, and you get 120 degrees. So that's how you get 240 degrees. Okay, so if you put in a label, it's probably help you to avoid mistakes. Okay, okay, so 240 degrees. So 240 degrees is going to be 8 numbers on the clock. Okay, so that's 3, 6, 7, 8. Okay, so it'll be eight numbers. So you're going to end up at 7 o'clock position. So again, that's equal to 240 degrees. Okay, number 15. Okay, 3/4 of a clockwise. So clockwise is this way, revolution. Okay, again, first let's go and convert into degrees. Okay, so 3/4 revolution times it by 360 degrees for one revolution. So this revolution will cancel out, this cancel. So this will equal to 270 degrees. Okay. So you're going to go 270 degrees going this way. So you go this way, you're going to end up right over here. Okay. So this is actually, so because you're going this way, so it's negative. So instead of that, it's negative 270 degrees. Okay, because you're going clockwise. Okay, let's go to 17. Okay, 1 3/5 counterclockwise revolution. Okay, first convert this into improper fraction. So you got 8 over 5 revolution. Okay, convert to degrees. You're going to times it by 360 degrees for one revolution. So revolution will cancel out, and this will cancel with that. And so this will equal to, okay, and it's counterclockwise, so it's positive. Okay, so this is 1 3/5 revolution. So you go 1 revolution and 3/5. And to know how much is 3/5, again, you can minus 360. So you're going to get 216. Okay. So here's 180 degrees over here. So 180 and you 36 more. So right over here. Okay. So again, one number on the clock is equal to 30 degrees. Okay. Okay, so A, name two angles, one positive, one negative. They are coterminal, and B, give a formula for measure for all angle coterminal with the given angle. Okay, so it's 15 degrees. Okay, so A. So to get coterminal, all you have to do is keep adding 360 or subtract 360. So if you add 360, you get 375 degrees. Okay. If you subtract 360, again, you can use your calculator. Okay, you're going to end up with negative 345 degrees. So again, to find the coterminal means you go around the circle one time this way or going around the circle one time. Okay, so if you go counterclockwise, if you go this way, you just add 360. If you go this way, you minus 360. Okay, so one positive, one negative coterminal. Okay, and then to find the formula, you just use 15 degrees plus n is number of times you go around the circle times 360 degrees. Okay. So again, n is how many times you go around the circle, and each time you go around it's 360. Okay, so that's the formula. Okay, number 21. You have the negative 100 degrees. Okay. So again, if you add 360, you get 260 degrees. Okay, again, that's the positive one. The negative one, you just minus 360, means you go around the circle this way. So you're going to get negative 460 degrees. Again, you can go around the circle as many times as you want. Okay. So B, your angle would be, you can use this one. Again, because all these are coterminal angles, so you can use this one, you can use this one, you can use this one, you can use any one. Okay? And normally you want to use the lowest positive number whenever possible. So it would be 260 plus n times 360 degrees. Okay. Again, you can use any numbers over here because all these are coterminal angles. Okay? But usually you want to use the lowest positive number. Okay? Okay, 23. Okay, 520 degrees. Okay, so that's minus 360. You get 160 degrees. And to get a negative, just go and minus 360 again. Again, every time you go around the circle, you adding or subtract 360. So this will give you negative 200. So again, the problem asks for one positive, one negative. So to get negative, you just keep subtracting 360 until you get to the negative. Okay, to write the formula, again, you can use this number, you can use this number, you can use this number. But normally, you want to use the lowest positive number. Okay. So again, this is your angle, and you can, basically what you're saying is that you can get to the same position by go around the circle. Each circle that so n is number of times you go around the circle, and each time you go around is 360, right? Okay. Okay, number 25. You have 3605 degrees. Okay. Okay, so this number is really big, so I'm going to really lower my number by keep unwinding the circle. Now, one circle is 360, so if I go around 10 times, it would be 3,600. Okay, so again, I'm going to unwind 10 times, and so I get 5 degrees. Okay, and if I unwind one more time, so minus 360 more, I get negative 355 degrees. So again, I minus 10 times the 360. Okay. So B, again, you can use any of the number. Normally, you want to use the lowest positive number. Okay, so plus n times n times 360 degrees. Okay. Now n can be a negative number. Okay, so n, if it's positive, it's going counterclockwise. If n is negative number, means it's going clockwise. So again, n can be any integer, positive or negative. Okay, number 27. You have 42 degrees 30 minutes. Okay, in order to convert to the nearest tenth of a degree, Okay, so it's easy if you use calculator. Now to enter on your calculator, depends on the calculator. Different calculator enter differently, so make sure you know how to enter. Now for this calculator, I have to enter 42.30. Okay. Then I have to convert into decimal degree first. Okay, so second, and over here, DMS stands for degree minutes seconds. DD means decimal degree, so I go second, and this will give me 42.5 degrees. Okay. Okay, 29. I have 72 degrees and 40 minutes. Okay, again, so on here, I have to enter 72.40 second DMS to DD. So I get 72 point, and this one you want to run it up to the nearest tenth. Okay, so 72.6666 will give you 72.7 degrees. Okay, so to the nearest tenth. Okay. Okay, next one. Okay. So this one you want to be more accurate. You want to get additional digits, hundreds of the degree now. Okay. So you got 25 degrees, 45 minutes. Okay. Okay. So you can on your calculator you enter 25.45. You go second DMS to DD. Okay. So this will give you 25.75 degrees by hundreds of decimal place. So the two digits. Okay, next one, 33. You got 6 degree, 21 minutes, and 30 seconds. Okay, so on the calculator, again, different calculator can enter different keys. So for this calculator, you have to enter 6.2130. So put a decimal right over here, so it'll be 6.2130. And you go second, and this button over here, and this will give you 6.36 degrees, 6.35333, but you run out to the nearest hundreds. Okay, so they give you 6.36, and remember to put a little circle to indicate the degree. If you don't put a circle, then it's wrong, because if you don't put a circle, it means it's a radian, it means something totally different. So make sure you have a circle right over here to indicate the degrees. Okay, let's go to the next one. Okay, you have 65.4 degrees, and you want to convert into minutes and nearest, or convert to the nearest minutes, degree and minutes. Okay, so this one is much easier. You just enter 6.54. And you go, then you have to push this button. It says DD, so it means decimal degree, convert into degree, minutes, and seconds. Okay. And so this will give you 65 degrees, 24 minutes, and 0 seconds. And this one they only ask you for the nearest minute. Okay, so it'd be 65 degrees, 24 minutes. So 65 degrees, 24 minutes. So make sure you get all the labels in there correctly. Okay. Okay, next one. Okay, you got 23.9 degrees. You can get your calculator. So you got 23.9 second. This one here. So 23 degrees and 54 minutes. So 23 degrees and 54 minutes. So the degree, minutes, and second, it work exactly just like the clock. Okay, so the degree will be similar to the hour, minutes, and seconds. So they work exactly the same way. Okay, okay, number 39. Okay, this one, you're going to do it, you want to convert into degree, minutes, and seconds to the nearest second. Okay, so you got 30, okay, so number 39, you have 19.41 degrees. Okay, so 19.41 degrees, you convert into DMS. So this will give you 19 degrees, 24 minutes, and 36 seconds. So again, this means this means minutes, this means seconds. Okay. Okay, number 41, 57.67 degrees. Okay, so again, get your calculator, 57.67 degrees, and you convert into DMS. So you get 57 degrees, 40 minutes, and 12 seconds. Okay, next one. Okay, number 43, you have the coordinate -3, 3. Okay, so you want to draw the angle and use a protractor to find its measure. Okay. So -3, +3. Okay, so get 1, 2, 3. 1, 2, 3. Okay, so it's going to be right over here. Now, so you want to find an angle. So if you were to draw, so this is your -3, 3, right? So if you use your geometry, if you draw this down, notice that this would be a 3. This would be a 3. So this is a 45 special triangle. So this would be 45 degrees. So therefore, so this is called an alpha. Okay, and this is called a theta. So theta is always start from the horizontal axis. Okay, so this is called a reference angle, and so this angle would be, remember this is 180, right? So 180 minus 45. Okay, you start with something that you know, and to get back you have to go backwards. So from here you start 180, and you want to get to here, so you have to minus because you go in this direction is minus. So theta equal to 180 minus 45, so equal to 135 degrees. Okay, 45, your coordinate is 4, 3. Okay. So this coordinate 4, 3. Okay, so this one it says draw an angle and use a protractor to find its measurement. Okay, so if you have a protractor, you can use it. If don't, then don't worry about it. Just go and estimate the best you can. So this one looks like it's going to be about 37 degrees. So it's about 37 degrees. Okay, number 47. So you have the square root of 3, 1. Okay, so square root of 3 is about 1.7. Well, from your geometry, this is your 30-60 spatial triangle, right? 1, 2 square root of 3. So this is your 30 degrees. So in this case, your theta is 30 degrees. Yeah. So you have to kind of remember a little bit from your geometry. Okay, number 49. You have -1, negative square root of 3. Okay, so you got -1 and negative square root of 3 is about 1.7. So that's your -1, negative square root of 3. Okay. So again, from your geometry, okay, this would be your 60 degrees, and this is 180. So therefore, the theta will equal to 240 degrees. Okay, because you start with 180 and you go this way, you add, right? So 180, you add 60, give you 240. Okay, let's go to the next one. Okay, number 51. Okay, it says find the fourth quadrant angle, which an angle 4 times as large would be the given quadrant. Okay. Okay, so you're going to get a second quadrant. So if you notice an angle in the second quadrant, okay, so let's call this theta. So to be in the second quadrant, you have to be greater than 90 degrees and have to be less than 180 degrees. Okay. Well, okay, let's go and call this. Looking for the angle, so let's go and call this. What should we call this? Let's call this angle. Let's call this x. Okay, for now. So you're looking for theta over here. That 4 times that will equal to that. Okay. So 4 times the theta would be in the second quadrant. Okay, so that's what we're doing. Okay, so we don't even need that. So again, 4 times the angle would be in the second quadrant. Okay, so that's what you have. So to find theta, you have to divide it by 4. So that way you're going to get 22.5 degrees would be less than theta, less than 45 degrees. Okay. Okay. Now, in a book, they always have, we just kind of use the very basic one. You also can, to get a coterminal, you have to add, n times 360, right? So to get all the answers, you just plus n times 360, okay? And same thing, 45 plus n times 360 degrees, okay? So you want to be more precise that this is for all the angle end up right over here, okay? But we're just going to stay with this, okay? So this is fine, this is good enough, okay? Because it didn't say you have to get all of them, right? It just says find A means find a first quadrant. So we found 1, so that's good enough. If it says find all, then you have to use that, okay? Okay, so just kind of make that clear, okay? Quadrant, so this one is going to be in quadrant 4, okay? So 4 times theta would be in quadrant 4, okay? So 4 times theta, right? Again, 4 times so that the 4 times the as large would be in this quadrant 4. Okay, so to be quadrant 4, you have to be greater than 270, have to be less than 360 degrees. So again, 4 times the angle theta, that it will end up right over here. So just divide by 4, divide by 4, divide by 4. And so you're going to end up with 67.5 degrees is less than theta, less than 90 degrees. Okay. So again, the problem asks you to find one of them. Okay. So this is good enough. If it says find all possible, then you have to do that. Okay. Okay. Let's go to next one. Okay, so this one, the 6 times as large, so 6 times as large, so 6 times the theta will be in quadrant 3. Okay, so quadrant 3 is over here. So that means you have to be greater than 180, but you have to be less than 270 degrees. Right? Okay, so again, number 55. Okay, so the angle 6 times the angle would be in the 3rd quadrant. Okay. So divide by 6 on each part. So you can get 30 degrees is less than theta, less than 45 degrees. Okay, 57. So find the angle that which half as large. So half as large, Okay, half the angle of the given would be in the first quadrant. So to be in the first quadrant, it has to be greater than 0, and it has to be less than 90 degrees. Right? Again, quadrant 1. Okay, so it'd be here's your 0, here's your 90 degrees. Okay, so to get that theta, you just multiply it by 2. So you're going to get 0 times this will give you theta, and it will be 180 degrees. Again, you just say find an angle, so all you have to do is find one, any one would be fine. Okay. Now, if it says find all, then you have to do the formula, right? Again, this is for all. Okay. When you have this, means this is all the possible angles. And this is just one of them. Okay, 59. So again, half of the angle would be in third quadrant. So quadrant 3 is over here. So this is 180, this is 270. So it has to be greater than 180 and have to be less than 270. So again, multiply by 2. Okay, then you get 360, and then you get theta and less than 540. Okay, and that's it. Okay, number 61. So 1/5 as large, so 1/5 the angle would be in second quadrant. Second quadrant is over here, so that's 90, and this is 180. So it has to be greater than 90 degrees, it has to be less than 180 degrees. Okay, so all you have to do is just multiply by 5. So you get 400. So you got 450 degrees is less than theta, less than 900 degrees.